Hello, I'm Aurora Wentz and today I'm going to be demonstrating how to create an XLR cable. To do this, we need a balanced cable, a soldering iron, solder, a male and female XLR connector, snips, and optionally, wire strippers and something to hold the connectors in place while soldering. Additionally, it is helpful to plug in and turn on the soldering iron before preparing your balanced cable so that it is already hot when you need it. For 60/40 solder, your iron should be around 356 to 392 degrees Fahrenheit or 180 to 200 degrees Celsius. To prepare my balanced cable for soldering, I take my snips and nibble back approximately 3/4 of an inch of the casing from the cable, being careful not to cut the shielding. Sometimes, it is helpful to bend and twist the cable to help get the casing separated. After I get the casing off, I separate the shielding, twisting it into one wire to keep it out of the way and to make sure I don't cut off any of the small wires later on. My cable also has strings around the hot and neutral wires. I separate and carefully snip it off. Now we can see our hot, neutral, and ground wires. The hot and neutral wires are just made out of copper on the inside, but it is best to keep with the common system of using red for hot and black for neutral. If you do not have red, and instead have a white wire like me, use that for hot. To finish preparing my wire, I use my wire strippers to cut back approximately 1 to 2 millimeters of outer casing on the hot and neutral wires. I find it helpful to twist together the small wires that are revealed in order to keep them from separating while soldering. Finally, I make sure that my hot, neutral, and ground wires are all approximately the same length. We're almost ready to solder, but first, we have to put on the shell of the XLR connector. You can also do this before preparing your balanced cable. Now it's time to solder. XLR connectors have 3 pins. Shield is pin 1, hot is pin 2, and neutral/low is pin 3. Before soldering, it is helpful to pre-tin all of the elements. This is where we put solder on all the elements we will be soldering by heating up the element and then touching the solder onto it, making sure it fully melts. You are not trying to drip the solder onto the different pieces. It is also important to note that once wires are pre-tinned, they become somewhat immovable, so make sure that you don't have any little strands poking out. Twisting them ahead of time helps to ensure this. Now for soldering. I am starting with my shield on pin 1 to make sure that I have a good anchor. Having a solid anchor point makes it easier to solder the other 2 wires. While soldering, I make sure that all of my elements are touching at once. I touch pin 1 and the shield at the same time for a couple seconds and wait to remove the iron until the solder from our pre-tinning is fully melted. Then, I add a little additional solder to make sure that everything is firmly joined together. In between soldering the wires, I make sure to clean off my iron's tip. This allows it to stay clean and stay hot. Then, I repeat this process 2 more times for the hot and neutral wires, being careful not to remove my hand and keeping it all steady while it cools. Making sure the iron, the elements we are soldering together, and the solder are all touching at once helps to prevent cold solder joints. Cold solder spots might look uneven, have a rough surface, and look detached. Finished products should be firmly joined together and have a smooth-looking surface. Often, you can fix a cold solder spot by remelting the solder. Now that everything is soldered, I pull up the shell and put on the casing of the XLR connector. To finish the cable, you will repeat the entire process on the other end. Once you have done so, congratulations! You have soldered an XLR cable. But it is important to make sure that you've done it correctly and that your wire is sturdy. To ensure this, we test it. I like to wiggle around the ends of my wire to make sure that nothing breaks off. Then, I go through with either a cable tester such as the Behringer CT100 or a multimeter on the continuity setting. Once on the continuity setting, I put one of my probes in pin 1 of my female connector and touch pin 1 on the male side. If the cable is wired correctly, the multimeter will beep. I then touch pins 2 and 3 on the male side to make sure that I do not hear a beep while touching those pins. This ensures that nothing is cross-wired. I then repeat this process for pins 2 and 3. If your testing goes well, then congratulations! You now have the knowledge to create your own XLR cables.